All right, so I'll reopen the session for this afternoon. This is the last talk of the OpenCL track. We have a recorded presentation from Siva, and Hongxiang will be able to answer questions after the talk. So let me get this started right away.
Hello all, myself Shivramakrishna. I am from Qualcomm India Private Limited. Today I'll walk you through open source deep learning compiler solution updates for Adreno GPU, primarily covering the TVM and MLC communities updates. The agenda is primarily walking you through the MLC or TVM solution for running generative AI models on Adreno GPU, and the range of models that we have benchmarked, and then we do support as of today, and some of the prominent models performance also will be shared to you. And we do support the same TVM and MLC solutions on Snapdragon products running on Windows platforms. So I'll share some of the details in that side. And finally, I'll wrap up by showing what is it that's going to coming in the near future in these two communities' direction. We are part of Qualcomm GPU research team from Bangalore. Our main focus is to explore and enable open source AI solutions for the Adreno GPUs. We primarily contribute to TVM and MLC communities. With IWOCL, we have been updating the community with the latest and greatest things that are happening in these communities with respect to OpenCL backend. Here is few resources and the links that relates to this context. Primarily the TVM community and then the MLC LLM community. And on top of that, we are recently started giving an SDK kind of a release wherein which these projects has been compiled by enabling the necessary options that are required for running on Adreno GPUs. On top of it, there are quite a few blogs that we keep releasing with latest and greatest news around these communities. Let's take a deep dive into MLC or TVM solution for generative AI in the context of Adreno GPU. It all starts from the models which are coming from these publishers. We'd be like Llama from Meta, or a GPT range of models from OpenAI, or the Gemma models from Google, or the Pi models from Microsoft, or many other publishers like DeepSeek, Mistral, Qwen, and many more. So when these models are being given to the MLC, what MLC does is MLC has this model conversion or templates with it. It technically builds the models as a TVM relax modules. So we learned the architecture from these papers that is released by these publishers, or by looking into the models that are being there. We represent these modules as relax modules here. And then we'll do a weight conversion. Weight conversion is important because we cannot accommodate such a huge parameters coming in these LLM models onto the edge devices. In the context of Adreno GPU, we use Q4 F16 quantization. What it means is we take a group of 32 values in the parameters and then quantize them as int 4 and repackage such values into an int 32 and store them back. And at the time of consumption on running on a target also, we do a inline dequantization followed by execution. Hence, there will not be additional RAM, additional staging where we do dequantization and storing, and all that will happen at the runtime as well. And then MLC has quite a few optimizations, primarily to give performance benefits while running these models on the targets, which includes a good way of handling the KV caches or using batching when you have longer prompts, and many other novel techniques like speculative decodings and employing different attentions and all that. Finally, MLC emits a group of modules that is responsible for running this whole model on the target, and the parameters that are quantized, and then finally the tokenizers that are specific for every model. All that are the artifacts that comes out of the MLC. Now, when we take all these things to TVM and then really want it lower and then generate the shaders and the target executable artifacts that are required for us to run them on the target, TVM as usual starts with the front ends, but front ends may not have any job in this case because MLC has generated the relax modules already. So they directly go with the graph optimizations, wherein which TVM employs its own ways of graph optimizations, be it like fusion or constant folding or many other standard things that TVM does at this level. And then once the high-level graph optimizations are done, now this is the place where we realize each and every layer that is there at the relaxed level to a kind of a schedule, and then it will go to the lowering. So at this point of time, in the context of Adreno GPU, we have two options. One is we can generate the code in the TVM's way by using the OpenCL public spec, or we do try to offload some of these layers to a vendor specific path. Qualcomm has its own extension that is built on top of OpenCL, which is the MLOps library, which will give you at most of the times a better performance on Adreno GPU compared to the kernel that are being generated by the OpenCL public spec. And after that, obviously TVM finishes does separate the original graphs accordingly, which will execute on the OpenCL ML side, or which will execute by using the public OpenCL spec, and then it will generate the artifacts for running on the target. And when these artifacts essentially is like a very standard artifact that TVM gives in general, like an SO file containing all the shaders and all that, and then the parameters will come as it is, because TVM will not do much for the parameters. And finally, when we try to run it on the targets, it starts by the MLC orchestration, because TVM can handle one relax module at a time, but for the generative AI solutions, you need this additional orchestration, primarily because you have a different module for decode, and then you have a different module for prefill, and then there is a whole bunch of persistent data that need to be handled as KV cache and all that. So the MLC orchestration will take care of all that at the high level. And when we go to the layer here, the low level, the TVM runtime level, we see the VM executor, which primary job is to handle one relax module execution. And then one level below that, in the context of Adreno GPU, again, we have two runtimes. One is primarily to load and then execute the OpenCL public spec based shaders, and then other thing is to execute the OpenCL ML based shaders execution on the GPU. And at this level, there is one more additional component that TVM has added primarily to cater few of the special needs that the MLC requires, that will accommodate the KV cache related optimizations, primarily things like zero copy, or and we do have few optimizations there to accommodate copying of the data at the host level without again enqueuing a copy command for the OpenCL and such kind of things. So all that will go into this LLM support module to really give that additional performance that is needed out here. And finally, be the OpenCL device API or the CLML device API, both of them will pass through the Qualcomm's OpenCL SDK before it actually reaches the Adreno GPU hardware. So the overall solution is driven by the strong open source advantage we leverage from the communities, along with our deep understanding of Adreno GPU, is what enables this overall solution for us. Here is the model support and the performance details from MLC or TVM solution. MLC from the community, it supports about 220 plus models covering about 60 plus architectures from various researchers that are listed in the previous slide as well as out here. Here is a link where you can look after every model and its variant, and then what is the parameter size it supports and all that. And depending on the parameter size, most of them are compatible to run on Adreno GPU on all the targets that we have Adreno GPU, be it be a mobile or a compute platform running Windows, or even the auto platforms of Snapdragon devices targeting the Linux, and then as well as the IoT platforms. The effort is as simple as you need to recompile. If you have a target platform that with a different operating system and all those things, you just need to recompile this MLC and MLC TVM solutions as well as those models for those targets. And functionally, ideally, they're supposed to be working. So here is some of the prominent model performance on Android devices. We are showing out here two Android devices, Snapdragon 8 Gen 3 and then Snapdragon, the latest one is Snapdragon 8 Elite. And the table shows you the models from DeepSeek, Llama, and Meta, and some of the models. We are not covering all the wider range of it. Yeah, probably you can give it a try by taking our SDK and then building other models, and then please let us know if you have any regression on the performance of those models. Here, the columns for every model, what we are showing is the benchmarking is done by for the decodes as well as the prompt processing. Decode is primarily measured by decoding 100 tokens given any prompt, and the encoding is being benchmarked by giving it prompt of size 256, and we are showing out here the tokens that it could actually process as part of encode and prefill or encode process. And there is a column that will tell you how quickly the model can start emitting an output when you are given a 256 sized prompt. So here is few of the blocks. I think I already listed them in the previous slide also. Since these blocks will tell you how to get started with running these models on Adreno GPU. As you all know, the latest Microsoft Copilot Plus PCs are powered by Snapdragon X Elite. We now have a range of Snapdragon X Elite powered devices from Lenovo, HP, Asus, and many other OEMs. In the current context, all these devices can run the MLC or TVM based Gen AI solution we are detailing here. Here is few prominent model performance for the Snapdragon X Elite device. Yeah, Snapdragon X Elite has a slightly powerful Adreno GPU than the mobile devices, hence the same thing is being reflected in terms of improved decode tokens as well as the improved prompt processing performances here. All the enhancements or support we give for TVM or MLC projects is relevant to any Windows platform powered by the Snapdragon with the Adreno GPU in it. In this section, I'll show some of the new features or ongoing activities that we are going to bring into these communities that will really enhance the Adreno GPU performance with this solution, as well as the other things that we are committed to contribute for these communities. To start with, the first thing is OpenCL ML for the generative AI. As you all know, generative AI workloads can be categorized into two parts. One is the decode, which is primarily the DDR bound, because you'll be for every token generation you need to pump in every parameter that is there for generating every token. And on the other side, the prompt is primarily an ALU intensive operation where the predominant operation is matrix multiplication of 2D versus 2D matrix multiplication. So in our observation, the Adreno GPU with the OpenCL public spec cannot really utilize the ALU for the maximum possibility. So in the past also we have done the similar kind of a thing. The OpenCL ML backend, in which we offer the range of kernels that can really perform much better compared to an OpenCL kernel that is being generated by the public spec. So on the same lines for generative AI also, we have optimized a few of the generative AI layers and then packed them into the OpenCL extension, and then now we are going to have an OpenCL ML extension that is primarily offers additional layers that are required for these generative AI workloads. So this can technically boost the performance of prefill, and in our early analysis, it can boost nearly a 2x performance for the prefill processing. The next one is towards relax. As those who is already familiar with the TVM community and its recent directions, TVM has phased out the relay, and then I think it's already phased out, and then we are now TVM officially continues to support and enhance only the relax. What it means to us is, I mean, in fact, the MLC completely uses the relax. It doesn't use any relay. So to avoid redundant efforts and then maintenance and all that, community has already moved on to the relax. So what it means to Adreno GPU is the optimizations we have done in the past in the context of relay has to be brought into a relax and then made them available for the community, so that there'll be only one single repository that will cater the traditional CV and these kind of models, as well as the latest and greatest generative AI models as well. So these efforts are already in progress. We already have raised few PRs onto the community that primarily bring in early CLML offloading into the relax, as well as we are already a few PRs in progress to bring in the texture based off texture utilizations, and then all those options that we already have in relay will be slowly will come into the relax, and then we will be in line with the community guide directions in terms of compatibility, as well as we'll continue to enhance the relax for all the upcoming features that we want to bring into these communities. The third one is Vulkan ML backend. This is entirely a new effort which we started recently. Primarily to give one more alternative backend that can really give the performance on par with the OpenCL backend that we have in Adreno TVM. So TVM already has a Vulkan backend, but when you try to run the generated code with that backend on Adreno GPUs, it's not comparable to the performance that you get with OpenCL backend, even though the underlying hardware and GPU is the same thing. So we, as we know what is it that need to be added on top of it to really get the better performance on Adreno GPUs, we have added all those enhancements to the Vulkan ML backend as well. This still yet to be mainlined. We do have now functionally and performance-wise working version internally that can match the performance of OpenCL generated shaders, even if someone uses the Vulkan ML backend for Adreno GPUs. And thanks to TVM's target independent nature of optimizations, because we could leverage all those optimizations we have done for OpenCL ML at the very high level, and keeping only the code gen and the runtime related changes that are required for few of the aspects like texture based objects creations and things like that. So you'll be seeing pretty soon you'll be seeing TVM community supporting Adreno GPU with both OpenCL and Vulkan ML backend with more or less the similar kind of a performance. Here is the disclaimer more about various different terminologies and trademarks that we used across these slides for your reference. And thank you for listening to my talk.
So yeah, this mentioned earlier, we have two approaches to run large language models through the open source projects. One is Llama CPP, the other is TVM MLC. And this is the MLC part of the story. Now feel free to, if you have any question. Maybe I can mention a few things. Yeah. So Qualcomm officially has this Qualcomm Neural SDK. That's actually a Qualcomm official product, commercial product. So it's maintained by a bigger team, much bigger team. So, but it's a black box. So it actually supports CPU, GPU, and NPU. We actually more focused on NPU. So yeah, this SDK is highly optimized and maintained by big team, and quality definitely is the commercial quality. The downside is the time to market. It's a black box, so it's a proprietary offering. If you have a new model, sometimes, yeah, it's going to take a while to get the performance to the level you expect. So the open source effort is really from the separate team, so the GPU team. Just try to leverage the open source community in the best way to enable customers directly or indirectly. Yeah, we are a relatively much smaller team, so that's why try to leverage open source projects. Yeah.
So, I have a question.
Yeah.
So you were talking about Copilot on Windows.
Yeah.
So you're distributing your framework on OpenCL on Windows. Any feedback about the Windows ecosystem for OpenCL?
So Copilot, actually, today Microsoft, I think the Copilot, they have a lot of models running behind. That's mostly on NPU. So for this open source projects, we are actually providing the solution. The customers are evaluating at this stage. We haven't really get a strong opinions on these solutions. So it's ongoing right now. Yeah, we do work closely with some big laptop makers. Yeah, this front. Yeah.
That's definitely something the OpenCL community should be made aware of when it becomes distributed, because for me that's a real success story here.
Yeah, so our goal again is just to make developer life a lot easier. If you want to try, run a large language model on your local, either on smartphone, Android smartphone, or IoT devices, or Windows on Snapdragon, just feel free to use these open source projects. So we have detailed instructions on how to build, how to run. So feel free to give a try. Welcome any feedback. You don't have to pay, if you're a local model, you don't have to pay to OpenAI like $20 a month in subscription fee. Yeah, so also the privacy, latency of running local is much better than running on cloud. So, if you're on an airplane without the internet, you can still have this local model running. So it's much better than, the cloud one.
All right. Any more questions? No. Thank you very much.
Sure. Thank you.